Hello, hello everyone. Can you hear me? Hello, am I audible? Hello, can you guys hear me? So, host can you hear me? Can anyone? So, what we'll do is we'll wait for a few minutes for us to join, and then we'll begin the session. Okay. Right now we have like only 8 people. Okay, 8 students. So, 8 of you guys. So we'll wait for a few more minutes, and then we'll begin session. All right. But can you guys hear me? Can you guys hear me? Can someone confirm that you guys can hear me?
Yes, sir.
Vijay. Okay. Thanks. Okay. So let's wait for 5 minutes and then we'll begin session. Okay. And before that, I know that we have like there were some few mistakes in the quiz paper. We'll rectify that. Okay. Yeah. We'll wait for a few minutes and then we'll begin. Okay. We'll wait for 2 more minutes and then we'll begin session. Okay, so let's begin session. I think we will not have many other students joining, so we'll begin session. So in this session, what we'll do is we'll do the solve with us as well as the practice assignment, problem solving. Okay, we'll do both. Okay, first let us do the solve with us. Okay, after that we'll look at the practice assignment problems. Okay.
So here, can we discuss problems?
Yeah. We'll be discussing problems.
Yeah, because in lectures, most of the concepts are theory, no problems are discussed for
Right.
week 10.
Yeah. This session is entirely dedicated to solving problems. So we'll be solving problems. Okay.
Okay.
Yeah. So first we'll do solve with instructor one. So where I'll be giving you as 4 problems to look at. Okay. And after that we'll look at the solutions for them. Okay. Okay. Just 1 second. Let me just share my screen. Are you able to see the screen? Are you able to see my screen? Is it visible?
Yes.
Right? It's visible. Yes. Yeah, okay. So this is a question what you are asked to do is among the following sets, right? Which of the following are convex, closed, and bounded? Okay. So it should be closed and bounded on. Okay. I mean, what is closed means is that the area which it occupies, it should be finite, and the bounded means that the values it could take, that also will be bounded. Okay. I mean it's like some finite. It should be within a specific range. Okay. So yeah, look at this sets A, B, C, D, E, F. Okay. For all of this, right? X comma y belongs to R square, right? This is the domain, and this is I mean x square plus y square is less than or equals to 4. This is can serve all the points. Okay. So the same thing we have here for different one. Okay. Different conditions, based on this you could plot it and then look at it. Okay. So among the A, B, C, D, F, which one of it will be the is convex, closed, and bounded? Okay. So solve for this. I'll give you guys 10 minutes to solve this. Okay. Just plot these graphs, then it will be evident for you. Okay. You should be looking at whether it's a convex or not, closed and bounded, both. Okay. This is not a MCQ question, so more than one option could be correct. Okay. So please keep that in mind too. So those of you, the student who joined now, right? Yes, we are solving few problems from the week 10. So this is the first question. Like among the following sets that were given, you should be selecting the convex, closed, and bounded one, right? All these three should be like satisfied. Please look at those and then select the corresponding one. Please do not paste your answers in chat box. Please do not do that. How did your quiz 2 exam go? Hello, like any feedback on quiz 2 exam that you have written? So when you guys are done, please raise your hand, okay? So that we look at the. I mean, once enough people have raised their hand, we look at the solution. Okay? So please raise your hand once you're done with the problem. So once again, I'm repeating this. So more than one options could be correct. Could be, okay? Please raise your hand if you're done with the problem. Raise your hand if you're done with this first problem. Okay. We'll discuss the solution in 2 more minutes. Okay. Okay, so shall we look at solution? Hello. So shall we look at the solution? You guys are there, right? Okay. Okay. Yeah. So let's go ahead with the solution. If you look at this first one, right, x square plus y square is less than or equals to 4, we know that the circle is a convex one, and the thing is, it is closed. Okay, it is closed and it is bounded. I mean, like it is bounded by this by the x square plus y square less than or equal to 4. Right? Whatever points we have, that's like within this itself. So this is convex, okay, and this is like this is closed and bounded too. Okay, so this one is like true. I mean, the first option, right? First option which we have, that is true. Okay, and the second one is this y equals to 2x plus 4, right? Look at that. The points which we had, right? Okay, it's not closed. Okay, it's not closed one, and moreover it's not a bounded one. So the values which it could take, it's like infinite. Okay, three. This is x could go to infinite and y could go to infinite. So it's not bounded to. Okay, so option B is wrong. Okay, if you look at option 2, x plus y less than or equals to 2 and x greater than equals 0 and y greater than equals 0. Okay. X plus y less than or equals to 0 and x greater than equals 0 and y greater than equals 0. Okay, so basically what this means is we are just including this region, this rectangular region, okay, not the entire one, but just this this 0 to 2 0 to 2 this y limit of 2 and this x limit of 2. We are having this small triangle, right? Okay, right triangle, right angle isosceles triangle. Okay, this is the only region. Okay, and the values which it could take, okay, which it could take, that's like bounded one. Okay, and it's also closed because it's also closed because we have the limit here, right? Like the values x comma y could take, right? There's a limit for that, so it is bounded. Okay, and we know that this line anyway it's a convex one. Okay, so yeah, so this one is true. Okay, C is true, and if you look at the option D, y greater than x square. Okay, let's look at that one. Okay. If you look at here, this is like first thing, y equals to x square one, that is convex. Okay, that is true. I mean, it's convex. It's convex, but the problem is that here it's not closed. Okay, this is not closed because we could see here there is no this upper closing one. Okay, this keeps on like extending, and then it's not even bounded. Okay, the values y and x could take, that's like infinite. Okay, so it's not like bounded at all. So option D is wrong. Okay, if you look at option E, xy is greater than 1. Okay, xy greater than 1, we could see here this entire region, right? This entire region falls under this. Here we have these two options of like x greater than equal 0 and y greater than equal 0, right? Which falls under this region. Okay, which falls under this region. Even here x is not, x and y, they are not like closed. Okay, they are not even like bounded. Okay, even this one is not correct. Okay, and if you look at it, even this other case of this xy greater than 1 and x less than or equal 0 and y less than or equal 0, even that is not correct. Okay, because this is not bounded and that's not close to. Okay, so we need not even look at the convex part for us to say that E and F are not the correct options. Okay, is this clear?
Yes. Yes.
Okay, let's move on to the second one. So now we have this two functions, f of x equals 3 plus x square plus x and g of x equals e power minus x. Okay, what can you say about their composition h1 equals to f of g? Okay, and then like yeah.
Yeah, is there any other way to find whether it is convex without the graph?
Okay, yeah, there is this, right? Like we if you do this f double dash of x, right? If you do this f double dash of x, if f double dash of x is always like positive, right, irrespective of what the x value is, then that's like convex, right? We have seen this in the previous week 9. Okay,
So if double derivative is positive, then it's
positive. Yeah, always like greater than or equal 0, then yeah.
Yeah, okay, that Hessian matrix fxx into fyy minus fxy also that one.
Oh, can you repeat?
So that using that double derivative fxx fyy minus fxy whole square, whether it is positive or negative, is that you are mentioning?
Fxy, this one you're talking about?
Not this one. Yeah, double derivative with respect to x into double derivative with respect to y minus the mixed derivative whole square. That Hessian matrix, determinant of Hessian matrix.
Yeah, see, in this particular case, right? Like in this particular case, correct. Yeah.
Okay.
What you could be doing is take this xy equals to 1 case, and then like y equals to 1 by x. Okay, y equals to 1 by x. You could just look at for that particular case. Okay, y equals to 1 by x, and then for this you could do the double derivative. Okay, for this you could do the double derivative and then check for it. Okay, am I making sense?
Yes, sir. Okay.
for here, like this is just similar to this, right? Instead of giving a x comma y equals r2, what you mentioned is we mentioned f of x equals 3 plus x square plus x. Okay, this you could write as like y equals 3x 3 plus x square plus x, right? It's the same. Okay, but anyway, we could do the double derivative to check like whether it is convex or not. Okay, check for this. For this problem, you can use a double derivative to solve for it. For example, if you have this 3 plus x square plus x, if you do the double derivative, the double derivative is going to be equal to 2. Okay, so like irrespective of what the value of x is, it's always the double derivative is always 2, right? So this 3 plus x square plus x, this is convex. Similarly, for g of x equals to e power minus x, if you do double derivative, it's going to be equals to e power minus x again. Okay, so no matter what the value of x is, e power minus x is always positive. Okay, so that's why we say this g of x is always also as like convex. Okay.
So here f and g are convex, right?
G are convex. F and G are convex, but you need to be finding out f of g and g of f. If you're done with the problem, please raise your hand. So just to reiterate, okay, like what I have told us, like the double derivative, it should be positive. That holds true for like single dimension. That is like y equals to f of x kind of thing, like f of x, f of x kind of thing. For that works. But for other ones, the partial derivatives, right? If you have the matrix of like double partial derivatives, then the eigenvalues of that particular matrix, it should be positive, right? It should be positive semi-definite matrix. Okay, the double derivative one. Okay, that was mentioned in the previous week. Okay, it was mentioned in the lecture 9.6. Could follow that. Okay, but for our problem that works. I mean, what I have told previously, the double derivative, if it is positive always, then that works fine. Okay. Are you done with the problem? Are you done with this? Hello. Shall we look at solution or do you want more time?
Open a solution.
Okay.
So is it in week 9, sir?
Yeah, the double derivative definition, that's in the week 9. Week 9 last lecture 9.6. Okay. So now what do we have? We have this f of x as 3 plus x square plus x, right? So we have this f of x equals to 3 plus x square plus x, and then g of x equals to e power minus x. Okay. First we'll go for g of x, which will basically mean that it should be f of e power minus x, right? Which will be nothing but x square, so e power minus 2x, right? Plus e power minus x, right? Am I correct until now?
Yes.
Right. So this is convex. This is convex because if we do this double derivative, right? This was mentioned as h1 of x. So double derivative of this, it's going to be equals to 4 e power minus 2x, okay, plus e power minus x. Okay, this is always positive. Okay, e power minus 2x is always positive, e power minus x is always positive. So the sum of this is always positive. Okay, so h1 is convex. Clear? Like h1 is convex. Is that clear? F of g of x, is that clear?
Yes.
Okay, so now we'll go for h2 of x. So which is nothing but g of f of x. This will be equals to e power minus of 3 plus x square plus x, right? Am I correct?
Yes.
So this is nothing but e power minus 3 into x, okay, minus x square minus x, right? And now, is this correct? I got a d power a plus b as like e power a and d power b. Am I right? Correct? And okay. So we'll do the double derivative for this. So this first we'll do the single derivative, which to like single derivative, it's going to be equal to this equation. I mean, ignorance sense, like since this is a constant, we just like don't have to worry about it. Okay, that's still gonna be there, but just for computation purposes, just since we're just checking for the sign, right? I'm like ignoring that part. Okay. So if you consider this as like it's going to be equals to e power minus x square minus x into the derivative of this one. So minus 2x minus 1, right? So what about the h2 dash of x? It will be equals to e power minus x square minus x. First I will differentiate this, later I will differentiate this. So to differentiate this, it's going to be equals to minus 2. Okay. And then if you differentiate this part, so it's going to be equal to minus 2x minus 1 again. So plus of 2x minus 1, this minus 2x minus 1 into minus 2x minus 1, that's going to be equal to 2x plus 1 whole square. So 2x plus 1 whole square, okay, into e power minus x square minus x, right? Until now, is it clear?
Yes, sir.
Okay, so if I just combine this coefficients, right, minus 2 and then 2x plus 1 whole square, right? We could just expand this, so it's going to be equals to 4x square plus 4x plus 1 minus 2 into e power minus x square minus x, okay? And this is going to be equals to 4x square plus 4x minus 1 e power minus x square minus x, okay? And this is not positive for all values of x. You could just see that for when x equals 0, right, is going to be negative, okay? So h2 double dash of x is not always positive. Okay, it's not always positive, which basically means that it is not a convex function. Okay, so h1 is convex, but h2 is not convex. Okay, h1 is convex and h2 is concave. h1 is concave and h2 is convex. For us to say, yeah.
So if it is not convex, then it is known as concave.
No, actually, ideally that's not the case. It will be concave when minus of a function is concave. Sorry, convex. Suppose let's say this h2 of x, right? This h2 of x, I can say it is concave when minus h2 of x is convex. Okay, so in this particular case, if you do the minus of it, that is it's going to be equals to just 1 minus 4x square minus 4x, and that's not convex. So wait, let's just look at the solution which was mentioned here. Okay, this is convex, that's clear, that part is clear. So, but if you look at this, right, e power minus 3, this one, this is not convex, this is not convex, but it is like a e power minus 3 plus x square plus x. Let's look at our differentiation which we done. E power minus x square minus x minus 2x minus 1. If you differentiate it, it's going to be minus 2, correct? To express a whole square into, yes. So based on the graph, for this, right, that is e power minus 3 minus 3 plus x square. This appears, I mean, this is concave. Okay, because we have this is like opposite of the convex. Okay. But we are not able to get that part using the derivative. Okay, let's try this again. We have this function as e power minus 3 minus x square minus x, right? E power minus 3 minus x minus x, correct? So this will take it as h1 of x. h1 dash of x, the first derivative is going to be equals to e power minus 3 minus x square minus x multiplied by minus 2x minus 1. Then double derivative of this, it's going to be equals to e power minus 3 minus x square minus x multiplied by minus 2x minus 1 whole square. Okay. If we now we'll take this as constant, and now we'll do the derivative for this, which gives us minus 2 e power minus 3 minus x square minus x. We are at the same point again. Four x square plus 4x minus 1 into e power minus 3 minus x square minus x. This is straightforward for us. This minus 3 plus x square plus x. This one is clear. Oh. But let me just look at this one. This g of f of x, that is c power minus 3 plus x square plus x. Okay, I'll look into that. Okay, based on the graph, it's coming out as concave. Okay, but that's not pretty evident while we're doing the double derivative. Okay, I'll check for this. Okay, but this f of g of x, that is like convex. That part is clear for us. I'll look at the second part and then I'll explain that later. Okay. So let's look at the problem 3. We have here, we need to maximize this x plus y. Okay. We need to maximize the x plus y subject to the following constraints. X and y both are greater than 0 and minus 3x plus 2y is less than or equals to -1 and x minus 5 is less than or equals to 2. Okay, so they're asking, is the feasible region bounded or unbounded? So basically the solution which we're getting, right, they're asking whether it is like bounded or like unbounded. Okay, so what you could do for this is you could just draw the graph. Okay, based on graph it will be evident for you. Okay, is this clear what I was trying to say?
Yes, sir. Yes, sir.
Right, you could draw the graph of like x plus y first, and then x greater than equal 0, y greater than equal 0. You can just shade the regions. Okay, the regions like which contains like I mean which is like shaded by this and all this, right? Which contains all these regions. I mean which region satisfies all these, right? That's our solution. Okay, once we get the solution we should check whether the solution which you got is bounded or unbounded. Okay, yeah.
So, sir, questions regarding Lagrange multipliers.
Yeah. What question to Lagrangian multiplier? Yes.
Yeah, is there questions related to Lagrange multipliers?
You,
Are they
you
coming below?
Yeah, we do not have that question here. Okay, so we'll discuss that from the practice assignment. Okay, we have
When,
the
sir?
we have the linear regression problem. Okay, but we do not have this Lagrangian one. Okay, the Lagrangian one we'll discuss from the practice assignment. Okay,
When is that session, sir?
we'll discuss it now itself. I mean, like
Okay.
today in this session itself.
Yes.
Once you're done with the problem, please raise your hand. So we'll discuss the solution in few minutes. So please raise your hand when you're done. Okay. Shall we discuss solution?
Yes, sir.
So now if you look at this, right? We have here x is greater than or equal to 0. This x greater than or equal to 0, y greater than or equal to 0. That's nothing but the first one. Okay, and then we have this minus 3x plus 2. Minus 3x plus 2 is less than or equals to minus 1, right? What does that basically say is that, right, it should be yeah, so it includes all this region. Okay, so all this region which comes under this, like, let me do another one. So this includes all this green colored region. Okay, all the green colored region, and then this region will be d will be this x minus y is less than or equal to 2. Okay, this will be this one. Okay, all this upper one. So if you combine these two, right, we'll be having this region. Okay, we'll be having this CD, right? In between this CD, we have this common region, right? So that's the one. And then what we need to do, we need to be we need to be maximizing this express by, right? So if you are to maximize express by, right, then for us, right, there's no this bounded region, right? This region is like infinite, right? It's not bounded. So it's this the feasible region, right, which is this common region in between the C and D, okay, which we have over here, right? That's unbounded one. Okay,
Yes.
clear?
Yeah.
Okay, now we'll go for this problem number 4. Okay, so you're given a set of data points on the labels. Okay, for this, for 1 comma 2, the output is this 2.5. Okay, for this 2 1.5, this y value is 3, and then 2 3 5. Okay, we need to perform the linear regression on this data set. Okay, let the initial w at t equals 1, that is the first iteration. Okay, this is 0.1. Okay, I mean the w vector, right, which we need to do. Okay, that is this one, the initial w value they are given using gradient descent algorithm, right? And using a learning rate of 0.1, which means that eta is 0.1, we need to calculate the next w value. Okay, the weight vector for t equals 2. All right, so basically you just need to do that wt plus 1 equals to wt minus eta del f, right? The del f part, if you do, then that's like done. Okay,
So here, how to do that del f part?
we have this formula for that, right?
X into x transpose x is that?
Yeah.
Yeah, by but here what is x here?
X is this this matrix, right, which we have. See, we have here x as this 1 2 2 1.5 2 3 3 4. That is x.
So for 4 cross 2 matrix.
Yeah.
Oh, that is x. And y is that 4 cross 1.
Yeah.
Okay. So here, what if w is not given and we have to find w?
Come again. What if
W is not given and we have to find that w star.
whenever you're going for gradient descent, right, we should be having the initial w. That is this initial arbitrary point where we start from, right? That initial weight, it will always be given to you. Okay.
Okay.
Because if that is not given to you, if you choose a particular w, right, you'll be getting a different w after some iterations. Like after this first iteration, right, you'll get a different w value. Okay, at t.
Yeah.
So it will be
Here,
always.
what is w? What it signifies?
What this w signifies? This one.
So what is w? What is the meaning of that?
Okay, so we have this y equals to w transpose x, right?
Yes, sir.
Correct. So when we have this y equals to w transpose x, what does that say? We
Y
have
is equal to w transpose x.
W transpose x, right? So
Yes.
we have here this w. It kind of like this x is what it has this two values, right? 1 2 or like something, right? So basically this is the first feature, this is second feature, correct? Kind of.
Yes, sir.
Okay, this w transpose, what do we have here? Suppose in the initial one they have this 0.1 transpose, right? Correct.
Yes, sir. Point on.
See, this is the w1, and then the transpose of it, it's going to be equal to 0.1. Okay, so if we do this 0.1, this is the weight corresponding to the first feature. This 0.1 is the weight corresponding to the second feature. Okay, this corresponds to the weight or the importance it plays in getting this value of y. For example, here, right, we have
It's
this.
like coefficients.
Can you repeat?
No, sir. It's like coefficient for in a linear equation.
Yeah. So this is if you have this as like x1 x2. So this will be like kind of like coefficient c1 x1 plus c2 x2. Okay. Yeah.
In practice assignment, I saw a question where it was mentioned that to find W by using analytical method.
Okay. Okay.
So what
So-
is it? Analytical method means?
The analytical method, by equating the gradient to 0, right, you'll get one, right? That is that analytical one.
Oh,
Okay.
by del F to 0. Oh, so x transpose x into x transpose x W minus, in that del F should be equated to 0, right?
Correct. Correct.
Oh, okay. Yes, I understood.
Once you're done with the problem, please raise your hand. Are you done with the problem? Okay, so
Yes, sir, done.
Hello. Shall we look at the solution?
Yes, sir, we can see.
Okay. So first thing, this is just like there's nothing new for us here. All we have is this normal one, the formula substitution one. We'll get the answer. Okay. Before we look at this, right? Just like okay, we have this gradient equals to this x transpose x. Multiplied by x transpose y. Oh, right, that's not the correct one. Formula for this gradient is x transpose x w minus x transpose y. Okay. The formula for the gradient is this minus x transpose y. Okay. So here is this x transpose x w minus x transpose y. Okay. We have here x equals to how much? First of all, for finding this w2, we need to get w1 minus eta gradient of f. Okay. This gradient of f is equals to this x transpose x w minus x transpose y. Okay, we have this x equals to from what was given. Okay, x equals to 1 2 2 1.5 2 3 3 4. One, 2, 2, 1.5, 2, 3, 3, 4. Yeah, so on the y values are 2.5, 3, 5, 7. Two point five, 3, 5, 7, right? So now if you do this, x transpose will be equals to 1, 2, 2, 3, and then 2, 1.5, 3, 4. Okay, this is going to be x transpose. Now when we do this x transpose x transpose x, it's going to be equals to nothing but this 1 2 2 3 multiplied this 1 2 2 3, which will give you this 1 square plus 2 square plus 2 square plus 3 square, which is what 1 plus 4 plus 4 plus 9, right? Which is nothing but 9 plus 9, 18. Okay, the first value in this x transpose x is 9, and then the second one is going to be this 1 2 2 3 multiplied with this 2 1.5 3 4. So it's going to be 1 into 2 2 plus 2 into 1.5 3 plus 2 into 3 6 plus 3 into 4 4. So it is 2 plus 3 5 5 plus 6 11 11 plus 12 23. Okay, this again it's going to be equals to the same one. I mean the other one, this value right here, it's going to be 2 1.534 multiplied by this 1234. So it's going to be again 23. Okay, x transpose x, it's always going to be symmetric. Okay, and the other one is this 2 1.534 multiplied by this 2 1.534, which will give you 2 square plus 1.5 square plus 3 square plus 4 square, which is nothing but 4 plus 1.5 square is 2.25 plus 3 square is 9 plus 4 square 16 25 29 31.25. Okay, the X transpose X is 31.25. Okay, now what do we have here? We need to find X transpose X, W, right? X transpose X, W, it's going to be equals to 18, 23, 23, 31.5. Until now, am I correct? The calculations, is this okay? So it's going to be 18 into 0.5 plus 23 into 0.5, which is going to be what? 18 plus 23 divided by 2. This is 41 divided by 2, which is going to be 20.5. Okay. 20.5 and this 23 plus 31.25 divided by 2, which is going to be 54.25 divided by 2, 27.125. Okay. Am I correct until now? We have this X transpose X, W equals to 20.5, 21.75, 27.125. Okay. Now we need to find this X transpose Y, right? X transpose Y is going to be equals to this 1223 to 1.534 multiplied by this 2.5357. Multiplied by this 2.53. Okay. If you do this, it's going to be equals to 1 into 2.5 plus 2 into 2, 1 into 2.5 plus 2 into 3 plus 2 into 5 plus 3 into 7. It's going to be 7 3 is 21 plus 10 plus 6. 21 plus 10 is going to be 31. 31 plus 6 is 37. 37 plus 2.5, 39.5. Okay, and this is going to be equals to 2.5. 2 into 2.5, 5 plus 3 into 1.5, that's going to be equals to 4.5. Okay, 4.5 plus 5, 9.5, 9.5 plus 15, 24.5, and then we have this 1 post 28, and this is going to be equals to 52.5. Okay, so now the gradient, it's going to be equals to what? X transpose X, W minus X transpose Y, right? So basically this minus this, which is going to give you 20.5 minus 39.5. How much is that? Minus 19. And this 27.125 minus 52.5, that's going to be how much? Can someone tell me? $52.5 minus 27.125. Okay, that's going to be equals to minus 25.375. Okay, this is the gradient one. Okay, now that we have the gradient, okay, this gradient equals to what? Minus 19 minus 25.375. Okay, now WT equals to W1 minus eta into gradient, right? So this W1 is nothing but this 0.5 minus eta was mentioned as 0.1, right? Minus 19 to 15.375. Okay, so this is going to be plus 1.9. Okay, plus 1.9 plus 2.5375. Okay, 1.9 plus So it's going to be equal to 2.4 plus, it's going to be 3.0375. Okay, this is the W2 value. Okay, did anyone of you get this value? No, they got this 3.64. Right. This we got it, x transpose y, and then x transpose x also we got it correct. This gradient W1. This formula is wrong. Okay, this formula is wrong. Okay, it's not x transpose x multiplied by x transpose y. Okay, so the answer one until this it is correct. Okay, but then the later part that's not correct. Okay. All right. Clear? Is this clear?
Yeah, it's clear.
Okay. Okay. Now we'll move on to the practice assignment. Okay, we'll solve some of the Lagrangian problems and then we'll close the session. Are you able to see my screen? Are you able to see my screen?
Yes.
Okay. So the first one is all right. Like
Sir, can we discuss that 10th one?
which one? 10th one?
Yeah, sir, that Lagrangian. Little bit below.
Okay. Okay. This one, 8 and 10. This one?
Yeah,
Correct?
8,
This one,
8.
right? 11th one?
Yes, sir, 8, 9, 10.
Okay. Yeah. 8 and 10 we'll discuss. So a rectangle has a perimeter of 20 meters. Using the Lagrangian multiplier method, find the height and width of the rectangle, which results in the maximum area. Okay, fine. So now, what is our area? What is our objective function? F of x comma y. This is xy, right? The area. Correct? And what is our constraint? X plus y is equals to x plus y equals to what? Okay, as a perimeter of 20 meters, right? So the perimeter is equal to 2x plus 2y, right? 2x plus 2y equals to 20 meters. So x plus y equals to 10. Okay.
Yes, sir.
And then we have this x is greater than or equal 0, and then like y is greater than or equal 0, because the height and width, right? That cannot be positive. I mean, that cannot be negative. Sorry. Okay. So first thing, how do you this thing, right? We will be converting this to x plus y minus 10 equals 0, 1. Okay. This is equality condition 1. Okay. It's equality condition 1. This is the equality 1. So for this, how do you get this Lagrangian one? Right? The Lagrangian of this f comma this if you consider this as like h1, right? It's going to be equals to xy minus v1 h1, right? Plus v1 h1, right? Okay. This is this f1 xy plus v1. V1 is this the constant which we're like taking. Okay, which we need to find the multiplier, the Lagrangian multiplier one, and then this h1 is this x plus y minus 10. Okay, this is equation. All right. So what do we have here? So for us, right? If you look at this, if you look at this KKT conditions, should be the conditions that should be satisfied? It should be that gradient should be equal to 0, correct? The gradient should be equal to 0, and then u star, and then this u1 star h1 this will be like this is not like applicable to us because we do not have this inequality condition. We just have the equality condition, and then for us this vj lj of x, right? This vj it could be like any value. Okay, we'll find out about the vj value using the first one itself. Like we can use the gradient equals 0 condition, and then we can find out about it. Okay, so let's do that. So this will be what? xy plus this let me just write it as v, and then the h1 it's going to be equals to x plus y minus 10, right? Correct. So we should be having this gradient equals 0, right? So this is my L1. So this gradient one, it should be equal to 0. So what do we have here? We have this dou L by dou x, it should be equal to 0, and then the dou L by dou y, it should be equal to 0. Okay, which implies for me xy plus b into x plus y minus 10, right? It's going to be what? X plus I mean, if I differentiate it, it's going to be equals to y. I mean, when I differentiate it with respect to x, right, it's going to be equals to y plus this vx. If we differentiate it, it's going to be equals to v. Okay, and then this x plus y minus 10 part, that's going to be 0. I mean, that's going to be 0. So we not consider that. So y plus v should be 0, will be 0. Okay, when we use this dou L by dou x condition. Similarly, when we use the dou L by dou y condition, what we get is we get this x plus v equals 0. Okay, correct? Right? So what this basically means, we have this we have this x equals to minus v, and then this y equals to minus v, which basically means this x equals to y, right? And then the other condition which we have this x plus y equals to 10. Okay, we have the x plus y equals to 10, which basically means that we have this x and y are equal, right? X and y are equal. Okay, since they both are equal to minus v, x and y are equal. If you get it, 2x equals to 1, x equals to 5. Since we got this x equals to 5 case, right, what you get is you get v as minus x or minus 5, which is going to be minus 5. Okay, so x as 5, and we got this y as 5, which gives the total area as maximum area possible as 25. Okay, the maximum, what is the optimal height? That's going to be 5. Optimal width, that's going to be 5, and then the Lagrangian multiplier, that's going to be equals to minus 5. Okay, clear?
So there it's given as 2.5 Lagrangian multiplier.
Lagrangian multiplier, that's given as 2.5. Okay. Okay, they would have done this. Instead of taking this as like 2x plus 2y equals to x plus y equals to 10, right? They would have done this 2x plus 2y equals to 20. 2x plus 2y minus 20 equals 0. Okay, we should have done this. We should not have like divided that part. Okay, so 2x plus 2y, and then this h1, right? It's going to be 2x plus 2y minus 20. Okay, which will give you this as like x plus 2b equals 0, right? And then like y plus 2b equals 0. Okay, and which basically gives you this b as minus x by 2 or like minus y by 2. Okay, clear?
So it's off. We you need to use the KKT conditions for this.
We did use the KKT conditions, right? See, we use the gradient equals 0 case.
Necessary to use that.
What?
Is it not necessary to use that KKT conditions for this problem because it's not inequality, right?
See, we did use the KKT conditions even with the equality case, right? We need to be using the KKT conditions. See, since we do not have this inequality, this is hi of x less than or equal to 0 case, only this part alone will be removed. But we do have this, right? We do have this. this gradient should still be equal to 0. Okay, this will not be there. Okay, this ui h of x equals 0. This will not be there. Okay, but we do have this vj case. I mean, what we need to use is we can just use this condition of like lj of x condition. Lj of x equals to 1 equals 0 case, and then the first condition itself, this gradient equals 0. It helps us solve it. Okay. This other two one, it's not like relevant for us because we do not have the inequality. Okay, we are still using the KKT, but like we are not using all. Okay.
Yes, sir. Understood.
Okay.
Yes, can we check the next one now in practice session?
Which one? This one?
11th one, the theory problem.
Okay. Dual of dual, it's primal. That is true. Okay. That part is like clear, right? If either the primal or dual problem as an infeasible solution, then the value of the objective function of other one is unbounded. That's correct, right? If you have looked at this this tutorial, there it was mentioned that the relation between this solution, right? That was mentioned. Look at it, right? It's like
Yes,
it has been the primal, right? It has been like, let's look at this. They said that if it has an infeasible solution, then the value of the objective function, right, of the other is like unbounded. So let's look at this. Unbounded, feasible. This impossible, right?
Yes, sir. Understood.
Okay. So the same one. And then if either a primal or dual problem has a solution, then the other also has a solution on the optimal value or equal. That's correct, right? Okay.
Yes, sir.
And then if one of the variables in the primal has an unrestricted sign, then the corresponding constraint in the dual is satisfied with equality. That was mentioned, yes. Okay. This should be this is also true.
Yes, sir. Okay. And fourth one, you can go, sir. 4.
Okay. This one.
Here we have to find that composition and just evaluate the second derivative.
Yeah.
Okay. And I was asking that fifth one for finding W. This is
Okay.
that they are asking to find optimal W star using analytical method. So just we have to equate the derivative to 0.
Yeah.
Transpose.
You should equate that x transpose x W minus. You have this, right? Where is
Yeah,
that?
sir. X minus X transpose Y.
Yeah. This x transpose x
I got
W minus x transpose y should be equated to 0, which gives you this W as
W equal to
x transpose x inverse multiplied by x transpose y. Okay.
Yeah, understood. Yes, sir.
Yeah.
And can you go to the graded assignment, sir? 1 minute.
Which one?
Graded assignment, the third one.
Okay.
Just I'm asking.
Graded assignment, yeah.
Procedure, yeah. Third one.
You want to look at this third one, choose the largest interval of x in which the function f of x equals to x e power x square is convex. Okay. So here basically what they were trying to ask is you
What
need
is
to
the
do
interval mean?
yeah, the interval in sense like the domain of x where it will be like convex.
Yes, it's okay.
Like, so see what you need to be doing is what's our like condition f double dash of x, that should be always positive, right?
Yes, sir.
Correct?
So in which area the f double dash x is positive, we have to find that.
Yeah. So like that particular large interval that you should be choosing. Okay.
Okay, sir, understood.
Okay.
And in graded 10th one, sir, it's 10th one, that Lagrangian function.
Okay. So they have Krishna runs a steel fabrication industry, produces steel products, he regularly purchases. Okay. Purchases raw steel for 500 per ton. His revenue was modeled by RSF equals to 100 root square S, where S is the tons of steel purchased. His budget for steel is 15,000. Sorry, 1.5 lakh. 150,000. Using the Lagrangian function, find the amount of steel to be purchased to get the maximum amount. 500 per ton, right? And his budget for steel is 1.5 lakh. To get the maximum revenue. This revenue, okay, this we should be like maximizing, right?
Yes, sir. So that f of x is 100 root s.
Yeah. What f of x is 100 root s? Yeah. That f of x is like 100 root s, and then the constraint for us is that this 500, like the cost for like 1 ton is what, 500, right? 500, right? 500 per ton, and then his budget for steel is what? 1.5 lakhs, right? What you should be having is, you should be having this 500x minus so this 500x should be less than or equals to this 1.5 lakh. Okay, so that you should be using. Clear?
Can you show how this question will be
Can you
done
repeat?
once? Sir, can you show how this question will be done? Like,
Yeah, you just need to write the constants. I just told you the constants, the objective function, okay, and then you need to write this Lagrangian function, right? Use the KKT conditions, find the derivative, and then like equate it to 0, okay, and then using that UIHA value equals 0, 1, you get the values. Okay, I can't be telling you the entire one. Okay, I have just told you the constraints, and then the objective function. Using that you can find. Okay, it's graded one, and then the deadline is not yet over, so we can't be discussing much about this. Okay, yeah, any other questions? Any other questions here? No?
So am I audible?
Yeah.
Yes, sir. I got sudden power cut, so I connected to other device.
Okay,
Yeah, sir. Can you show the solution once?
for this grade assignment one, or
Yeah, graded assignment 10th.
grade assignment we cannot be discussing it, sorry.
No, just you said some. What is the procedure?
The procedure for this,
Yeah.
for this problem.
Yes.
See,
Here, objective function is 100 root s, and what
yeah.
condition?
The condition is that we have this, the cost for like 1 ton is what, 500, right? 500, right? Let's say like he bought this S tons. Okay, he bought the S tons, right? So what is the cost for that? That's going to be 500 S, right?
So 500 is less than or equal to 1,50,000.
1,50,000. Yeah, that's the condition.
Only one condition.
Yeah, and then this S should be greater than or equal to 0. Okay, only that one condition. Yes.
Yeah, that's common one. And okay.
Okay.
Yeah, yes, sir.
Yeah. Any other questions?
So in the 12th one, graded, what is it, sir?
Okay, we give the vector W in R3. Okay, in R3 there are like many unit vectors. Using Lagrangian method to find a unit vector which gives the maximum dot product. Okay, this is like use Lagrangian method to find the unit vector which gives the maximum dot product with this vector, right? So basically what they're asking you is we have this W vector, right? Some
Yes,
vector,
sir.
right? So see,
Yeah.
corresponding to that vector, we can, I mean, let's say like I give you any other vector, right? Any other unit vector, okay? You can find the dot product with this vector, right? Correct?
Yes, sir.
So what they're asking you to do is they're asking you to, okay, which gives the minimum dot product. They're asking you for the minimum dot product. Okay, you should be choosing that XYZ in such a way that it should give the minimum dot product. So for example, we have here what is it value that was given? Let it be anything, okay?
Yes.
So we have this v vector as x, y, z. Okay, let's assume. And then I need to find this p vector. Okay, this, let it be x1, y1, z1. So this is going to be equals to x2, y2, z2. Okay. The condition here is that this modulus of v or the length of the vector v, that should be equals to 1, because they mentioned it's a unit vector. That's a first condition. And then the dot product of these two, right? That is this x1, x2 plus y1, y2, okay, plus z1, z2, right? This is the dot product, correct? I know this x1, y1, z1. Okay, I need to find x2, y2, z2. Okay, this is the dot product. Let this be, this is the objective function. Okay, f of x2, y2, z2, because those are the values which are unknown. F of x2, y2, z2 equals to this x1, x2, y1, y2 plus z1, z2. It should be a minimum. Okay, this should be the minimum. Okay,
Yes.
that's it. Yeah. For that, how do you find it?
So here no need to find the value of lambda.
The lambda value. Isn't the Lagrangian method? No, you need not worry about the lambda value. Okay.
No. Yes.
Any other questions?
And what they're asking in 7th question, sir, grade? I can't understand the question.
Seventh, linear programming deals with the problem of finding a vector x that minimizes a given linear function C transpose x, where x ranges over all vectors satisfying all the given conditions. X equals to b. Okay, here A is an M cross a matrix. Choose a correct dual problem with y as a dual variable for the above linear program. Okay. So what they're trying to say is that we have this objective function, right? For us, the objective function is what? C transpose x, correct?
Yes.
C transpose x, and then our condition is that x is greater than or equal to 0, and then this x equals to b.
Yes, sir.
Okay, so what they're asking you to do is just convert this primal problem into the dual problem with y as a dual variable. Okay, instead of this x1, it takes y as a dual variable.
Oh, yes, sir. Okay.
Okay. Yeah.
Yes.
Okay. Any other questions?
No, sir. That's.
Okay. There are no other questions, then we can close the session. Okay. No questions? Okay, okay then, yeah. Thanks. Everyone. Okay.
Sir?
Right.
Excuse me, sir.
Yes. Yes, sir.
So can you actually one question?
Can you? Yusuf, I'm not able to hear you properly.
With the Lagrange.
Can you?
Sir, can you actually solve one question of the Lagrangian to show the
I did solve one problem in the practice assignment. Okay, I solved for this. I solved for this problem xy perimeter 1. I did solve for that.
so in that only
In that only,
sir, I did the Lagrange.
you're saying that are you saying that it has only this equality condition? There is no inequality condition. Is that it? Yusuf,
There's no inequality condition. Examples.
you want an example with the inequality condition?
Yes,
Correct?
where we use those all KKT conditions.
Okay. For example, let's look at this. You have here one, Raul is a consumer who wants to maximize his liquidity. Some constraints, he consumes two goods X and Y, and the liquidity function is a product of X and Y. Okay, his budget is 1000. The per unit price of X and Y are 15 and 20 respectively. Okay. So here I'll try to solve for this problem. Okay, they just ask you to solve for the choose correct optimization and then the equivalent Lagrangian one. Okay, I'll solve for this. Okay, clear? So what do we have here? First thing is we need to maximize this utility, right? Correct. So which means that and they mentioned that the utility is equals to what? XY, right? XY, correct? And then what's the condition we have? The prices, right? The total budget which he has is 1500, 1000, and then the per unit price is 15x and 20x. So it should be equals to 15x plus 20y. 15x plus 20y. This is less than or equal to 1000. Okay. And then this x is greater than or equal to 0, y is greater than or equal to 0. That's like anyway implied. Okay. So now what's my objective function? So I have this 15x is 20y minus 1000, right? This is like less than or equal to 0. Okay. Should be having this as like xy minus lambda into 15x plus 20y minus 1000. Okay. This is the one I have written this as like minus because we want to like maximize this, right? We want to maximize this. So this should be like when since this is already 15x minus 20y minus 1000, this is less than or equal to 0, which means that if we take this as positive, this entire thing it's going to be positive. We're going to take it as like xy plus lambda into 15x plus 20y minus 1000. Okay. Now, what do? We just like do the differentiation part. So xy plus lambda into 15x plus 20y minus 1000. So this is the Lagrangian one. Okay, we do the dual by dou x equals 0. So which gives us what? Y plus lambda 15 equals 0. And then the other one is just x plus, this is the dual by dou x, dual by dou y, it's going to be equals to x plus 20y equals 0. Okay, 20 lambda, sorry. Lambda equals 0, and then which gives us what? Lambda equals to minus y by 15, correct? So if we substitute that here, x equals to minus 20 lambda, x equals to minus 20 into minus y by 15, right? X equals to 4 by 3 y. Okay. Now the constraint which we have, right? We have this 15x plus 20y is less than or equal to 1000, which basically means 15x. If we just replace this x with this 4 by 3 y, what you get is you get this 20y, right? Because it's going to be 15 into 4 by 3, that's going to be equal to 20y, plus 20y is less than or equal to 1000, right? Which basically means this 40y should be less than or equal to 1000. Okay, the maximum value which you could get for y is 1000 divided by 40, and it's going to give you 25. Okay, y is 25. Okay, which gives you this x as 4 by 3 into 25. Okay, and the maximum value which you could get for this is this xy, right? That is what 4/3 into 25 into 25. Okay, this is clear. How we are like able to maximize this? Okay, and then the lambda value will be
Yes.
if we just equate this. I mean, for us, right? Since we were like able to get this as 15x plus 25 exactly equals to 1000, right? This could like, I mean, this could be like any value. I mean, we can get the lambda value from this. Y lambda equals to minus 5/15, which gives us is y equals to 25, right? So minus 25/15, which is minus 4/3. Okay, lambda is minus 4/3. Okay, clear?
For lambda, so we have to equate only for the x.
Can you repeat?
Like the maximum value of x has to be equated to obtain lambda.
The maximum value
of
price
y,
must be
which is
equated to
going to
lambda. What? This one you're saying?
to get the value of lambda, we have to okay.
See, we have this condition, right?
So we have
See,
to put the value.
we have this condition, correct? Dual by dou x equals 0, correct? So we have this 5 plus lambda 15 lambda equals 0, correct? And x plus 20 lambda equals 0. Okay, and then lambda into 15x plus 20y minus 1000, that should also be equal 0. Okay, but the problem is that already 15x plus 20y minus 1000 is already equal 0. Okay, by using this equation we cannot get the lambda value. Okay, that is why we are using this equation or this equation.
Yes, sir.
Okay. Okay. Any other questions? Any other questions?
No, so that's it.
No.
No.
Okay. Okay.
Yes, sir, thank you.
Yeah. If there are no other questions, then we can close the session. Okay. Okay then. Yeah. Thanks everyone.
Thank you, sir.